Lesson 16, determining outliers from a set of data. An outlier is an observation that lies an abnormal distance from other values in a random sample from a population. How to find an outlier from a graph? It is marked with a star or dot outside of the box plot. So for example 1, it says determine the outlier from the graph below. So if I'm looking at this graph for the volunteer service hours, it says, is there an outlier, and what is the outlier? Well, there is no outlier. How do we know? There is no star. Or dot outside the box plot. So example 2 says determine the outlier from the graph to the right. Well, here's a star right here. So it says, is there an outlier? Yes. It says, what is the outlier? 18. How do we know? There is a star. At 18 outside the box plot. It says from a set of data, a number that is numerically distant from the rest of the data. So the next thing that we're going to do is we are going to be finding an outlier from a set of data, if there is one. So we should be doing 1 through 6, not E through J. So let me change those. 1, 2, 3, 4, 5, and 6. So in 1961, Roger Maris made baseball headlines by hitting 61 home runs, breaking a famous record held by Babe Ruth. Here are Maris's home run totals for his 10 seasons in American League. Does the data have an outlier? If so, what is it and how do you know? So the first thing that we have to do is find the upper and the lower quartiles. Well, because it's already in order from least to greatest, that was the most important thing. So the first thing we're going to do is cut our numbers in half. So here's our first half, here's our second. So my upper quartile is 33. My lower quartile is 14. So that's number 1. Step 2 says to find the inner quartile range. So when I subtract these, we have 33 minus 14, which is 19. So step 3, we need to multiply 19 by 1.5. And I'm going to get 28.5. So the next thing we have to do is to add the results from step 3 to our upper quartile. So when I add that to 33, I get 61.5. And it says, are there any data points above that answer? The answer is no. It says, what are the data points above this answer? None. It says, subtract the results from step 3 from the lower quartile. Well, my lower quartile is 14. So when I subtract 28.5, I get, and I want to double check this on my calculator. I get negative 14.5. And it says, are there any data points below this answer? Answer is no. So it says, are there any data points, and this should say below this answer. And it says, what are they? Answer is none. So it says, what are the outliers in this data set? So we have none. So next, it says, our next example says, does the following set of data have an outlier? If so, what are they? So the first thing we have to do is order our numbers from least to greatest. So we have 22, 24, 26, 26, 28, 31 and 31, 34 and 37, I need to cut them in half. So step number 1 is find my upper and lower quartiles. So my lower quartile is the average of 24 and 26. My upper quartile is the average between 31 and 34. So step number 2 says to find the interquartile range. Which is 7.5. Step number 3, we are going to multiply by 1.5. Step number 4, we're going to add 11.5 to 32.5. And we get 43. Oh, sorry, guys. I multiplied that wrong. It's 11.25. Sorry, guys. I had it written down, just wrote it down wrong. So 11.25. So we have 43.75. So do we have any numbers that are higher than 43.75? So the answer is no. So number 5, we are going to subtract our lower quartile, minus 11.25, and I'm going to get 13.75. And then do we have any numbers lower than that? The answer is no. So therefore, there are no outliers. And that ends our lesson.